When I come out here, I do a variety of measurements with salinometers and with dissolved oxygen meters, very similar to the same type of instruments I might use out on the harbor or on a pond or out in the ocean. So the differences that we would see chemically for a salt marsh are they're going to be a little bit fresher, certainly more fresh or more fresh water on when the tide is low and there's less ocean water coming in or less water coming in from the harbor. Salt marshes typically are estuaries, which are a combination of fresh and salt water. So when the tide is going out, they're going to be fresher or have less salinity than the ocean, which is about 33. Right now I'm looking at the salinity using this salinometer, which is a YSI 63, and the salinity is 30.8 parts per thousand. You'll remember that I just told you ocean water is about 33 parts per thousand. The harbor that we tested yesterday was about 31.8 parts per thousand. So this is a little fresher than the harbor, but really seems pretty salty. So this Spartina alterniflora that I'm standing on is putting up with a lot of salt water that would kill other plants. It's also going to have a pH that's pretty much like ocean pH, and the pH right now is 7.78 pH units. You might recall yesterday that I was telling you that pH for ocean water is 8.3. So this is pretty close to ocean water. If we came back here in about 6 hours on the low tide, this pH and this salinity would be lower because it would be more like the fresh water. And if we kayaked up the marsh, which is exactly what we do, and use these different instruments, the closer we get to fresh water, the more these numbers are going to sink down closer to 0 for the salinity and about 5 or 6 for the pH. The temperature is pretty warm on this marsh, and we can also look at things like conductivity and the amount of dissolved oxygen. So I'm going to switch out instruments here and show you about the dissolved oxygen. That's one of the biggest differences with the salt marsh versus the open ocean. The open ocean is a very oxygenated environment, whereas salt marsh is a very reducing environment, so the dissolved oxygen is going to be less in the salt marsh. So let's grab our dissolved oxygen meter and see what it's going to tell us. It's our handy dandy YSI Pro ODO that uses optical measurements to tell us what the dissolved oxygen is. This is a lot easier system than the old-fashioned membrane systems that some of you may have struggled with in the past. This basically shoots a beam of light into the water, and then that beam of light is transmitted at different speeds based on the amount of dissolved oxygen in it. This thing is easy to stabilize and calibrate, and it's something I like using out in the field because it's usually very effective. Now, a lot of the creatures that live here in the salt marsh have to deal with a very reducing environment. This environment is as different as from an oxygenated pond or from the ocean as Mars. It's got all kinds of anaerobic bacteria, some of them which exude pink colors, bizarre sheens that look like oil, and these are all things that are very different than what we would see here in the salt marsh. In the salt marsh, it's reducing. So the creatures that live here, oxygen is not as big of a deal, but because there's less of it. And here I've got about, and I'll turn it around so you can see it, the oxygen is related to the temperature and to the atmospheric pressure. And in this case, I'm in the upper water column and the oxygen is 152%. So it's super saturated from all of the phytoplankton that's growing in the water column. But if I get it down where all that mud is, it's going to be closer to, now it's down to about 52%, closer to the reducing area. So there's a layer of black mud, and as we're walking along in the marsh, if we move our feet, we'll see this black layer of mud immediately under a very thin oxygenated layer. And that black mud smells like sulfur and is producing hydrogen sulfide, which is that rotten egg smell that you smell every time you drive by a marsh. When you drive by a marsh, you're going to go, oh my God, what is that smell? Well, to a chemist, that's a great smell because that is a reducing environment smell, and that means that everything that's living there is doing fine.